Mark your own. Here we go. Oh, I have to add my favorite student. And Sirki. A skydiver is in free fall. She has been falling long enough to hit terminal velocity. Which of the following statements are true? 2 marks, there's 4 statements, so it'll be a half mark each. There are no forces acting on the skydiver because she's not accelerating. True or false? False, I agree. Good morning, good morning. The magnitude of the gravitational force is less than the magnitude of the force of air resistance. True or false?
False.
Why? That has nothing to do with it. We're not accelerating. So if we're not accelerating, then number 1. That's where we're on the first question. The net force on the skydiver is 0. Yeah, that's true, because we're not accelerating. Now, D is a different situation. Once the skydiver pulls her parachute and starts to slow down, the net force on the skydiver is up. True or false? True. Okay, so FFTT. Half mark each. Number 2, find the acceleration of both masses if there is no friction. This is a job for a free body diagram. I'm going to have M1G, normal force number 1, tension, M2G, normal force number 2, tension, and I'll make a little note. I'll call that F applied, and Paige, I'll label it just so I don't forget about it because dumber things have happened in my brain. Who's winning? Got to be F applied, so it's going to look like this. Winner minus loser plus winner, that equals M all A. How come I don't put M1G or M2G into my equation? Kai, I'm writing an equation along the rope. M1G and M2G, they'll show up if there is friction, but otherwise they won't show up. Oh, tension, yay. I'll end up with A equaling F applied divided by M all. It's going to be 42 divided by 10 plus 15. 42 divided by 20. Is there a good trick to dividing by 25? Divide by 100 and then times by 4. So it's going to be 4.2. No, that's wrong. 1.68? Is that right? Meters per second squared. If you got that 2 out of 2, otherwise I would give you a half mark if I saw that, a half mark if I saw that, a half mark for the numbers, and a half mark for the answer. Find the tension between both masses. I'm going to use mass 1 because in mass 1, tension equals M1A. If you used mass 2, you would have F applied minus tension equals M2A. It's going to be 10 times 1.68. Heck, I can do that in my head. 16.8 newtons. Is that right? I think. 1 mark, half mark, half mark. The following system is moving to the right and slowing down. Okay. Find the acceleration of the system. So I guess someone is pulling this with 42 newtons, but that 42 newtons is not enough to speed it up. M1G, normal force number 1. I guess now there's friction force number 1 to go with normal force number 1, tension. M2G, normal force number 2 to go with mass number 2, tension. Friction force number 2, and F applied. Ooh, who's winning? First of all, which way are we accelerating in this question, to the left or to the right? left, because we're moving to the right but slowing down. Remember, Newton's laws don't tell us velocity, they tell us which way we're accelerating. We're slowing down, we must be accelerating to the left. So who's winning? To the left. So strangely, my equation, Jack, is going to look like this. Winner, friction 1, minus loser, plus winner, plus friction force number 2 is a winner. Minus loser equals M all A. Is that okay, Marcella? Has to be that way. Tension still cancels. Yay. They want me to find the acceleration, so A is going to be friction force 1 plus friction force 2 minus F applied all over M1 plus M2. How much room did I give us? Not that much. Okay, so let's keep writing. Friction is going to be mu times the normal force. I don't know the normal force. Oh, but look. M1G plus mu M2G minus 42 all over M1 plus M2. If I plug in numbers, I'm going to end up with, what's mu? I don't know what's mu with you. 0.24 times 10 times 9.8 plus 0.24 times 15 times 9.8. Take away 42 all over 10 plus 15. Oh. 0.24 times, oh, hang on, Mr. Dewick. Is this a fraction? Bracket. 0.24 times 10 times, Mr. Dewick, 9.8, plus 0.24 times 15 times 9.8, minus 42. Close off the top, open up the bottom. 25. I'll add the 10 and 15 in my head because I can. Do I get 0.672? Is that right? Find the tension in the rope between the two masses. I think I'm still going to use mass. If you got that right, 3 out of 3. Otherwise, 1, 2, 3, 4. I would probably go something like this. Half mark for that. Half mark if I saw that. Half mark if I saw that. Half mark if I saw that. Half mark for the answer. That's 2.5 marks. You know what? I'd probably give you 1 mark for realizing that friction was the winner. Has to be. Find the tension in the rope between the two masses. So here, I think it's going to be friction force number 1 minus tension equals M1A. I would use that one even though tension was a loser because it's just less cluttered. Mass 2 has 3 forces on it, and it's just going to be a little more work. You could use mass 2 and you'll get the same answer. I'm going to do a swappy dance. And I'll get friction force number 1 minus M1A equals tension. So tension is going to be mu times the normal force. I don't know the normal force. M1G minus M1A. It's going to be, what's mu? I don't know what's mu with you. 0.24, 10, 9.8 minus 10.672. Tension equals 0.24 times 10 times 9.8 minus 10 times answer button. Double check for typos, as that looks right to me. Do you get 16.8? Yeah. If you got that, I would give you 2 out of 2. Otherwise, I would give you a half mark if I saw that, a half mark for getting the t by itself, a half mark for the numbers, and a half mark for the answer. Ooh, elevator questions. Free body diagram. Emily, I'm going to be a bit bold. I'm going to do a single free body diagram, and I'm going to adjust the arrows in my head. I know that the tug of war here is between gravity and the normal force. Right now, I've drawn them the same length. Can I just imagine arrows getting longer and shorter? And if you do that, I won't freak out. On a test, I would probably draw one for each one. And honestly, on a quiz, I should draw a separate free body diagram for each. This is how I would do it in my homework. And we're cutting corners just a little bit because it's the week before spring break. We're accelerating up, so I would say to myself, self, it's got to be normal force minus mg equals ma. And again, Matt, as far as I'm concerned, I can either give you the acceleration, like I did in this question, and say find the normal force, or I can give you the normal force, the scale reading, Jack, and say find the acceleration. It's the same question, really. Here, normal force is going to be mg plus ma. It's going to be 75 times 9.8 plus 75 times 1.6. And I get 855, is that right? If I had asked you what the scale read in kilograms, I could divide by 9.8 and say 87.2 kilograms. I didn't ask that, but as far as I'm concerned, Harsh, that's fair game. I can ask you to go on a scale from kilograms to newtons to kilograms to newtons to kilograms to newtons. Anyways, 855. If you got that, 2 out of 2. Otherwise, I would give you half mark for the original equation, half mark for getting the normal force by itself, half mark for the numbers, and a half mark for the answer. Accelerates downwards. If we're accelerating downwards, which is the winning force, Davis? Good. So it's going to be mg minus normal force equals ma. Swappy dance, it's going to be mg minus ma equals normal force. The normal force is going to be m, 75, g, 9.8, minus 75 times 1.25. If I'm lucky, I can bring back this calculation and just do a little backspace and editing. Minus, and not 1.6, but 1.25. Do y'all get 641.25? I'll write 641. I'll go to 3 sig figs. Same as before, half mark for the original equation, half mark for getting normal by itself, half mark for the numbers, and a half mark for the answer. Constant velocity. What's my acceleration if we're moving at a constant velocity? What's my net force? Same answer. So the forces are balanced. So I can just say, you know what? The normal force has to equal mg. It's going to be 75 times 9.8. 735. What about in free fall? What would the scale read? 0. We said this is why astronauts are floating on the International Space Station. It's not because there's no gravity, it's because they are in free fall. By the way, the Earth is in free fall around the sun, which is why you don't feel the sun's gravity tugging on you. The sun doesn't change your mass, the sun doesn't change your weight. So I guess here 1 mark, half mark, half mark. And here, just 2 marks, all or nothing, I guess. Can you give yourself a lovely score, please, out of 19? If you need to lawyer with me, now is the time. Otherwise, you can pass them towards the center.